Today we're going to talk about using the Pythagorean theorem. A couple of sections ago we talked about the Pythagorean theorem, a squared plus b squared equals c squared, to help find side lengths of a right triangle. Today we're just going to talk a little bit more about how we can use the Pythagorean theorem. So this first sentence up top, if the equation a squared plus b squared equals c squared is true for the side lengths of a right triangle, then we know that that is a right triangle. This is called the converse of the Pythagorean theorem. What we had first learned about with the Pythagorean theorem was if the triangle was a right triangle, then a squared plus b squared equals c squared is true. The converse basically flips those two statements around and says, if I'm given three side lengths of any triangle, and I plug them in, and the equation a squared plus b squared equals c squared is a true statement, then we can say for sure that it is a right triangle. So let's just see how that works. So basically we're given a triangle here. We don't want to look at the triangle and say, oh, it looks like a right angle. We want to prove it. It may not be a right triangle. It could be 89 degrees, it could be 91 degrees. We need to know that the angle that we see right here is actually, in true statement, a right angle. The reason I'm picking this angle is because if I look at these three sides, we know that if it's a right triangle, the hypotenuse has to be the longest side, so it would have to be this one, because 41 is bigger than 40, and number 9. So just remember that. The longest side is always the hypotenuse. So there is something that we want to remember. So using the converse, what we want to do is just take the equation a squared plus b squared equals c squared and plug it in. Well, again, we know that the 41 has to be the c. We know that the a and the b don't really matter which one you put with which, so I'm just going to put the 40 and the 9 in the two spots. Those are the legs. And really we're kind of trying to say, is that a true statement? We don't see any variables here, so we're not solving for a variable. We're just trying to go through and figure out, are these equal on both sides? So we get 81 plus 1600, and 41 squared is 1681. Then again, I look at the other side here. We get 1681 does equal 1681. That is true, which means that this is a right triangle, which means we also know that this would be a true 90-degree angle. So let's look at the next one. So in the next one, we again have a triangle. It doesn't appear that it's a right angle. We don't want to assume that it's not. These are not always drawn to scale perfectly, so we want to just kind of go through and see how do the numbers work. Again, we also do know a couple of things. This has to be the c, because 24 is the largest of those. So again, when we go to plug in our formula, 18 squared plus 12 squared equals the 24 squared. And it's a big question mark because we're not sure. So now we want to plug in what are those different values. Well, 18 squared is 324. 12 squared is 144. And 24 squared is 576. When I look at the other side, 324 plus 144 is 468. Well, this time they don't equal. What that basically is telling us is not that it's not a triangle, because it is a triangle, but because they are not equal, this is not a right triangle. We can see that it is a triangle, but what we know for sure, based on the converse of the Pythagorean, is that it is not a right triangle. So using the converse will help you determine if a triangle is right or not right. so that we can then use that information to go forward. So next we want to talk about the distance formula. So the distance formula is basically coming from the Pythagorean theorem, just kind of worked in a different way. It is a crazy looking formula. It's right down here. The distance, which is our d value, is the square root of this whole entire expression. Basically, you're going to take your two x values of your coordinates, subtract them from each other, square that answer. Then you take the y values and subtract them and square it. Add those two numbers together, and then we always do the square root last. This comes from the Pythagorean theorem. This diagram over here kind of tries to show you how basically what we're doing and trying to find this diagonal is create a distance here, which is your y minus your y's to figure the vertical height, which is straight down. X's minus x's would help you figure out your horizontal height going left and right. You would then hopefully appreciate coming straight down and going straight across gives us the 90 degree. And if we add those two, vertical height squared, horizontal height squared, it should equal the d squared, which is our hypotenuse. And then remember, whenever we have d squared at the last second, we always took the square root. That's where this final square root comes in. So we do all this other work underneath the square root sign, and then we get our answer at the end. And again, because distance is always a positive, we would ignore the negative that would come out of the square root and just take the positive. So let's just see how one of those looks. Okay, so here we have the distance formula being used. We have 2 points. What we're first going to look at is here we have x values here, and we have our y values here. So when we do our distance formula, remember, d equals, and we're going to do this big radical sign that's going to kind of stay there for a while until we can get the radicand underneath all solved. So the equation basically says, take the x's and subtract them. It doesn't really matter which way you subtract them, because once you do the square, it's going to make it turn positive either way. So we have 1 minus negative 4. On the second one, then we're going to add the difference of our y values and square that. So now we need to keep following down. So d equals, and on the inside we're going to get 1 minus negative 4 is 5, and we're going to square that. Then we're going to go to the other one, and we're going to do 5 minus negative 2 is 7, and we're going to square that. The next step, again, we keep that little radical sign for now. We know we're still adding in the middle. 5 squared is 25. 7 squared is 49. I continue over here. D equals 25, and 49 is now 74. And then with the calculator, I take the square root of 74, and we get approximately 8.6. So the distance between those two coordinates is just about 8.6. So to draw a picture on here, basically if we were drawing a picture on this, we would be trying to look at how we find those points on the graph. So I'm just going to pause the video and I'll show you what that looks like. So here is what we're trying to find, is that little diagonal there. So basically what we're going to do is, if we were to use our Pythagorean theorem, we're kind of creating the vertical and horizontal distances and making a right triangle. So if I was to go from 5 down to negative 2, and I was to come straight down, that would be a units, 7 units down. From this point, if I was to come straight across from the 1 to the negative 4, it will be going 5 units. And because I went straight down and straight across, there is my right angle. Then I can use my Pythagorean theorem, which would have been 5 squared plus 7 squared equals d squared. And then that's where we get the rest of this formula we can kind of jump into. We get 25 plus 49 equals d squared. That's the square root of 74. So that would be how we could also prove that that is the 8.6. So one's a little more visual, but the distance formula is what we want to start practicing to make sure we can work through it. So here on the next one, again, we're trying to find the distance between these two. One big, giant radical sign to start. I'm going to focus on my x's in red, so I'm going to say 7 minus 9 squared. Then I'm going to focus on my y's in blue, negative 3 minus 6 squared. I go down to the next line. 7 minus 9 is negative 2 squared. Negative 3 minus 6 is negative 9 squared. I move down to the next one. Negative 2 squared is 4. Negative 9 squared is 81. So basically we are looking for the square root of 85. Now, again, 85 is not a nice perfect square, so we're not going to worry about exactly what it is. We're going to take the square root of it, and I get about 9.2. That's using the distance formula. Now again, using the other one here with the graphing, just so you can see it. I'm going to pause it, get the first line on there, and then we'll come back. So again, our diagonal is going to look a little bit like this, plotting those 2 points. Again, if I just focus on going from the 6 all the way down to the negative 3 for our vertical change, I get a 9, and that's where that 9 squares comes in. Then to get my horizontal change, I would come straight across, and I would come over from the 9 to the 7, which is the 2 distance. That's going to form the right angle, which is going to then help me allow to use that. And with the Pythagorean theorem, I would be using 2 squared plus 9 squared equals d squared, which again comes back to the other side where we had the 4 plus the 81, which is 85, and then you take the square root of the d squared to get it to be the 9.2. So 2 different methods, same kind of final objective. Down here, last example we're going to talk about today. This one's going to take a little bit of work. What we're basically trying to do is we're looking at a football play where a player is running down the field. So their first thing is they're running from here down the field. They make a sharp cut and they go to the back of the end zone. What we're trying to find out is if we kind of look at his cut, do we know if they made a 90-degree turn, which would imply 90-degree angle right here? That's what we're trying to figure out. Well, how do we know? Well, the way we would know is if we would kind of create this distance here, find the distance of the 3 legs, which is going to be where we get a little time work here, and then figure out if it's a converse of the Pythagorean theorem. So I'm going to focus on each one. So here's our first one we're going to try. We're going to do D1. Big long square root sign. I'm going to take my x and my y's for the first one to plug those into the formula. So the first piece is 60 minus 30 squared. The y's would be 50 minus 20 squared. D1, again we're going to keep that radical sign for a while. I get 30 squared plus 30 squared, which is going to give me 900 plus 900. It's going to give me the square root of 1800. Now, I'm not going to run a calculator yet. We're going to kind of see why in a little bit. I'm just going to leave it like that, just to kind of see, and if we need to run it with a calculator later, we can. So now I'm going to focus here on D2, and we'll do that one in blue. We're just going to kind of focus on each one as we go. So D2, My 30 and 20 still are part of the points we're going to use. This time we're going to have the 80 and the negative 30. So this time I'm going to go 80 minus the 30 for my x's, and I'm going to do negative 30 minus 20. So our distance for 2, that's going to hang for a little bit. We get 50 squared. We get negative 50 squared. D2 is the square root of 2500 plus 2500. D squared is the square root of 5000. Again, I'm going to leave the square root sign for now. So next we're going to find D3. So with D3, we're going to come over here and see what we got for our spacing. Big radical sign, need a lot of room. We're subtracting the 650 and the 8 negative 30. So 60, let's try that again, 60 minus 80 are the x values, and 50 minus negative 30 are the y values. So again, D3, 60 minus 80 is negative 20 squared. 50 minus negative 30 is 80 squared. Okay, so the next step, negative 20 squared is 400. 80 squared is 6400, which means our D3 is the square root of 6800. So now what we want to do is we want to kind of say, well, we have all these distances. What are we going to do with them? Well, here's what we're going to do with them. We're going to use the converse. So we're going to go back over here. We're going to use the converse of the Pythagorean theorem. So if this is a 90-degree turn, that means a squared plus b squared should equal c squared. So what we're going to do is see if our distances fit that mold. So here's how this works. So we know that the hypotenuse is D3. It's the longest one. So here's the left side. So we have the D1 squared plus D2 squared equals D3 squared. Now if you remember back to squares and square roots that we talked about just recently, when I take the square root of something and then square it, remember we said that the squares and the square roots undo each other. Well, if this happens, when I do the square root of 1800 and then square it, I get 1800. When I do the square root of 5000 and then square it, I get back to where I started from. And the same thing on the other side, the 6800 comes out with that. So if I put those two things together, on the left, we equal the right. So now we can come back up to the top here and say, based on this information, yes, he made a 90-degree turn. Because we proved that it was a right triangle, that would tell us that he made a 90-degree cut into that corner. We also could figure out the actual distances if we needed to. The question was just asking if we're looking at a right turn or not. Pythagorean theorem is going to help you in a lot of different areas of how to solve things. Remember, Pythagorean theorem or the distance formula. Pythagorean theorem is helping us with distances in a right triangle.